Hello, welcome all of you to Chapter 9, which is about joints. And we're going to start with a definition of a joint. So a joint is an articulation. Here's a foot here. And it's really where two bones meet. Anytime you have an articulation, you have where two bones meet. Now it's interesting that certain articulations have a lot of movement and others don't, right? That's why we're going to talk about it so much. But as a general definition, it's where two bones meet. And the primary function then is to usually create a lot of movement. Some bones don't, but we will be talking about movement. And this chapter talks a lot about how we move and how our skeleton can move. It's very cool. So we start out by classifying them on exactly that, on how much can it move, right? So the first one would be a bony joint, and this is rigid. It has absolutely no movement at all. And a fibrous one would be one where it does have fibers in between. I'm going to give you examples of all of these. So this is just a general overview, and then we'll come back. Very little movement. Cartilaginous would have cartilage on there, and then a synovial joint, which is, shown down below here with the hip and the ball and socket, which is the most amazing of joints because it's able to move in so many directions. Very cool. So let's go back to the bonies here. The correct term for that, for a bony joint, is synostosis. So syn means together. Ostosis means formation of bone. So when two bones sort of fuse together and completely become one bone, you don't even see a suture there. We're going to say it's a bony joint. So look at the skull looked at in superior view. And here you notice that the eyes would be up here, right? There is a metopic suture because this suture is no longer visible after about age 2. So it fuses entirely and you see nothing. And if you're seeing nothing, it's not going to have any movement at all. Okay, that would be a synostosis, bony joint. Now, others, like we've been talking about epiphyseal plate, have fusings, and the same things can happen. You're going to have that cartilage that allows it a little bit of movement, and then once they fuse, that growth plate is not going to move at all. That's also a bony joint. So it's interesting to look at these data. I'm never going to ask you this on a test, but it's sort of interesting to be looking at it. How long does it take for that epiphyseal plate to fuse when it's the humerus, the head of the humerus? It's, as late as in your 20s, in your early 20s it could be. Radius 2, 20, 22, the femur head, and look at the variability. It's anywhere from, teen years to early 20s. And then the clavicle, too, is a long bone that has cartilage, and that will sometimes only fuse about age 30. So, and then they will become a bony joint. Okay, great. I'm going to skip that. Okay, a fibrous joint. Then we're on the second one. We had bony joint, now we're on fibrous joint. Is an immovable joint, and that one's called a syn together, arthroses. So it's a joint. It's not totally bony, but it is a joint. So here, when you look at the skull, look, the bony one is gone, right? It used to have one here, and that one's gone. But these that are left behind do have connective tissue in between here. And even though it doesn't seem like there's a whole lot of movement, there is a tiny, that's what I put, barely any movement. But there is the possibility of that moving a tiny bit. So your skull bones, with all these fusing, there's another, look, these are all down here. See, all these are these types of sutures. Okay, so sutures then are considered to be fibrous joints or synarthroses. Another type of fibrous joint is in the tooth. So this is very interesting, and they have a weird name. It's called gomphosis. So look at the tooth And then this is bone. So can you understand that this is a tooth sort of embedded in your bone? And if you were to enlarge this little piece here, you'd be able to see that there's an attachment here from the tooth onto the bone. So that's a periodontal ligament that's lining in here, and these collagen fibers that are extending and anchoring your tooth inside the bone. So all I need you to know is that that insertion of a tooth in its socket there is also a fibrous joint. You know that when you bite hard, there's a little bit of movement, right? You bite a popcorn that didn't pop, and it sort of hurts, but your teeth move a little bit. They're not going to just break. They move a little. Okay, more about fibrous joints. Another type of fibrous joint is that we see between parallel bones. So in the tibia and the fibula, you know, they sit side by side, and we look at them usually as bones without any tissue around it. And how are they not just sort of flopping away from each other? Well, they don't, because they have long fibers. They're collagen fibers that are going to attach, and you can see them here very well attached onto one bone and attached onto the other bone here, and it's going to hold them in that place, but there is a little bit of movement. Okay, so this is the tibia and the fibula, but it's also the radius and the ulna. Those two parallel bones that sit next to each other are going to have a bit of movement involved. This is called a syndesmosis. So these are so confusing. Syn together, desmosis is the binding. So they're sort of bound together. All right, so we move on to the third now. Those with fibrous joints, they have some sort of fiber that attaches them. Now let's go to cartilage, a cartilaginous joint. So the best example is what we've been talking about before. Look at this hand of a child. And there are regions here of the bone that hasn't yet fused, correct? So it's a temporary joint between the epiphyses and the diaphyses while the child is growing. And in between, where you see that space, is going to be cartilage. So chondrosis, or chondrus, is cartilage. So that's a syn together, chondrosis, a cartilaginous joint. Just to go back to some of those diagrams that we had, you have that articular cartilage that's going to make a joint with the other bone, and then this whole piece here of the epiphyseal plate that's still cartilage, and joining these two parts of bone. Hopefully that's all review right now. We also have cartilaginous joints in your spine, and that's called a symphysis. So you know that you have these fibrocartilage pads, correct, between bone, the intervertebral disc, and that's going to function as cushioning between these bones. And it's cartilage. It's cartilage involved there, and that is called a symphysis. And you've probably heard of the pubic symphysis. Also has a tiny bit of movement, especially during delivery for a female, and that pubic symphysis is going to just move around a tiny bit. Physis is to generate, so together generate. I don't know why that would remind us of the spine or pubic symphysis, but that's the term given to these cartilaginous joints. Oh, here's the pubic symphysis, and again, cartilage here, and providing tiny bit of movement. Not nearly enough. Believe me, this should be a hinge here. You could unhinge it, have a baby, and then hinge it back up again. That would work. Better design. You want to do this endochondral ossification. Remember, we talked about that before. Now we're coming back to it again. In endochondral ossification. But first, I'll let you read it. And the correct answer is, oh, I didn't give you a slide of that. The correct answer is D. Okay, so we get to the most sophisticated of the joints, and that's a synovial joint. And synovial joints are going to allow so much movement in so many directions. And I'm going to actually leave that for the next video because we're going to talk a lot about movement. Given this complicated joint, how can you move it? Is it up and down? Is it left and right? Does it rotate? Does it spin? What can you do at that joint? So let's stop it there. Thanks for listening.